Microservices architecture, often shortened to microservices, is an architectural style for developing applications. Microservices allow a large application to be separated into smaller independent parts, each having its realm of responsibility. Let's explore how microservices can benefit your business. Services architecture is a software design pattern that encourages the development of applications as a suite of small, independent services. Why microservice required for you? Flexible microservices are highly modular and can be deployed independently. This makes them much more flexible than monolithic applications, which are often difficult to change without affecting the entire system. Scalable. It's easy to scale individual microservices without impacting others. This allows you to improve performance by scaling only the needed services. Resilient. If one microservice fails, the others can run unaffected. This increases overall system stability and resilience. Fast. Microservices can be deployed quickly and easily, thanks to their small size and independence from each other. Easier to understand. Smaller services are easier to understand and work with than large, monolithic applications. This makes development and debugging simpler and more efficient. Different architecture of microservices. While there are dozens of ways to implement architecture pattern, three topologies stand out as the most common and popular: API REST-based topology, application REST-based topology, centralized messaging topology. How do I get started with microservices? Microservices seem like a great solution for improving web applications, but how do you start with them? Here are a few tips. Start small. Don't try to tackle your entire application at once. Start by converting a small part of it into a microservice. This will help you get used to the new way of working and make any mistakes early on. Use the right tools. Several tools can help you with microservices development and deployment. Choose the ones that work best for you and your team. Plan for failure. As with any new technology, there is always the risk of failure. Plan for things to go wrong and have contingencies in place. Communicate with your team. Make sure your team knows what microservices are and how they work. This will help ensure everyone is on the same page and avoid confusion. Have fun. Microservices can be great fun to work with. Experiment and see what works best for you and your team. Why are microservices the future of development? Microservices are the future of web development for many reasons. Flexibility. Microservices allow you to quickly and easily adapt to changes in your business or the marketplace. This flexibility is essential in today's ever-changing world. Scalability. Microservices make it easy to scale your applications as needed. This allows you to improve performance and meet the needs of your customers. Resilience. If one microservice fails, the others can run unaffected. This increases system stability and resilience. Efficiency. Microservices are small and independent, making them fast and easy to deploy. Simplicity. Smaller services are easier to understand and work with than large, monolithic applications. This makes development and debugging simpler and more efficient. Microservices are the future of web development for all of these reasons. How will microservices impact my business? Microservices offer several advantages over traditional monolithic applications, and more businesses are beginning to adopt them. But what are microservices, and why do you need them? We will cover the 5 core components of microservices. These advantages make microservices an attractive choice for businesses looking to improve their web applications. Microservices are composed of 5 core components. Services. This is the heart of microservices, where your business logic lives. APIs. These provide a way for services to communicate with each other. Databases. This is where your application data is stored. Schedulers. These control when services run and how they interact. Monitoring. This ensures that your microservices are running properly and collect data for analysis. How does each of the 5 core components of microservices architecture work? Services. This is the heart of microservices, where your business logic lives. In architecture, services are small, self-contained units that perform a specific task. For example, a service might be responsible for handling customer orders or processing payments. APIs. These provide a way for services to communicate with each other. APIs allow services to exchange data and functionality, making building complex applications from smaller components easy. Databases. This is where your application data is stored. Each service has a database tailored specifically to its needs in a microservices. This prevents services from interfering with each other's data and keeps the database structure simple and clean. Schedulers. These control when services run and how they interact. Schedulers ensure that services run in the correct order and that they are properly coordinated. They also allow services to be run asynchronously, which can improve performance. Monitoring. This ensures that your microservices are running properly and collect data for analysis. Monitoring systems keep track of all aspects of microservice architecture, from individual service health to overall system performance. This data can be used to troubleshoot problems and improve system reliability. A monolithic application is a single, large software application composed of all the code necessary to perform all the required business functions. Monolithic applications are typically deployed as a single unit and can be difficult to scale and adapt to changing requirements. What is microservices? Microservices architecture, often shortened to microservices, is an architectural style for developing applications. Microservices allow a large application to be separated into smaller independent parts, each having its realm of responsibility. Key differences between microservice versus monolithic. Commitment to technology. Microservice. The advantage of developing an application that follows microservices architecture is that developers have a wide variety of options for various technologies like operating systems, frameworks, programming languages, etc., for building an application. Continual commitment and dependency can be eliminated using a single stack of technology. Monolithic. In monolithic architecture, developers are forced to use only one technology, no matter whatever its limitations are. For example, when your application's framework is outdated, migration to a new, better framework will be very difficult and challenging. In such situations, developers should rewrite the whole application in a different programming language and on a new framework, making it riskier and more time-consuming. Isolation of faults. Microservice. Even if there is an error in any of the processes, the rest of the processes will be unaffected and can be run as all the services are independent and isolated from each other. Monolithic. On the contrary, in monolithic architecture, any kind of misbehavior in any of the components may severely affect the working of the entire application. Management of code. Microservice. On the other hand, microservice has a divided codebase. Codebases in microservices are broken into multiple code units, which makes them easy to manage and update. Monolithic. Monolithic code base sizes are huge. Due to the large size of monolithic codebases, it is very difficult for development teams for understanding and managing it properly. This further leads to the slowing down of the development processes. Developments and deployments are continuous. Microservice. Development, deployment, operation, and scaling of every component of microservices application are independent. Any update in any services of the application will not affect any other services. Also, there is no sharing of implementation or codebase between services. This leads to the ease of continuous development and the deployment of complex and huge applications. Monolithic. Its codebases are large, and the components are interdependent. This leads to the limitation of continuous deployment and development because a complete application must be redeployed to update any component. It is risky and affects all the background tasks, and connected service functions are also impacted. Scaling of application. Microservice. All the services of microservices applications are built as different modules. This leads to the team's division to different work, which further helps them change and update production easily. This makes the scaling of application easier. Monolithic. The scaling of monolithic architecture applications is a challenge to developers as it is a single package unit.
What is Kubernetes? Kubernetes is a portable, extensible, open-source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. It has a large, rapidly growing ecosystem. Kubernetes services, support, and tools are widely available. The name Kubernetes originates from Greek, meaning helmsman or pilot. Keats as an abbreviation results from counting the 8 letters between the K and the S. Google open-sourced the Kubernetes project in 2014. Kubernetes combines over 15 years of Google's experience running production workloads at scale with best-of-breed ideas and practices from the community.
Benefits of Kubernetes in production environment.
Configuring and scheduling of containers, provisioning and deployments of containers, availability of containers, the configuration of applications in terms of the containers that they run in, scaling of containers to equally balance application workloads across infrastructure, allocation of resources between containers, load balancing, traffic routing and service discovery of containers, health monitoring of containers, securing the interactions between containers, fault tolerance, on-demand scalability, optimal resource usage, auto-discovery to automatically discover and communicate with each other, accessibility from the outside world, seamless updates/rollbacks without any downtime. Importance of learning Kubernetes. Free cloud solution. Same solution for all the problems. DevOps culture practice. High-paid job availability.
Kubernetes exam.
What Kubernetes certifications are available? There are 2 major paths to Kubernetes certification. 1. Official CNCF certifications. 2. Platform-specific certifications. The official CNCF certifications test your mastery of Kubernetes. Those skills can be applied wherever Kubernetes is deployed. The official CNCF certifications are as follows. Kubernetes and Cloud Native Associate KCNA. This is a multiple-choice proctored exam with no hands-on elements. Certified Kubernetes Administrator CKA. This is a simulator-based hands-on proctored exam. Certified Kubernetes Application Developer CCAD. This is a simulator-based hands-on proctored exam. Certified Kubernetes Security Specialist CKS. This is a simulator-based hands-on proctored exam. Where can I learn Kubernetes? You can learn Kubernetes from Page Cloud Academy. Online computer training school built in Bangladesh with very affordable cost and quality learning. Page Cloud Academy offer Kubernetes courses in online batches as well as corporate training regularly.
Ansible concepts. These concepts are common to all uses of Ansible. You need to understand them to use Ansible for any kind of automation. This basic introduction provides the background you need to follow the rest of the user guide. Control node. Any machine with Ansible installed. You can run commands and playbooks, invoking usr, bin, Ansible or usr, bin, Ansible playbook, from any control node. You can use any computer that has Python installed on it as a control node. Laptops, shared desktops, and servers can all run Ansible. However, you cannot use a Windows machine as a control node. You can have multiple control nodes. Managed nodes. The network devices and/or servers you manage with Ansible. Managed nodes are also sometimes called hosts. Ansible is not installed on managed nodes. Inventory. A list of managed nodes. An inventory file is also sometimes called a host file. Your inventory can specify information like IP address for each managed node. An inventory can also organize managed nodes, creating and nesting groups for easier scaling. To learn more about inventory, see the Working with Inventory section. Modules. The units of code Ansible executes. Each module has a particular use, from administering users on a specific type of database to managing VLAN interfaces on a specific type of network device. You can invoke a single module with a task or invoke several different modules in a playbook. For an idea of how many modules Ansible includes, look at the list of all modules. Tasks. The units of action in Ansible. You can execute a single task once with an ad hoc command. Playbooks. Ordered lists of tasks, saved so you can run those tasks in that order repeatedly. Playbooks can include variables as well as tasks. Playbooks are written in YAML and are easy to read, write, share and understand. To learn more about playbooks, see about playbooks. Advantage of usage Ansible. Ansible is free to use by everyone. Ansible is very consistent and lightweight, and no constraints regarding the OS or underlying hardware are present. It is very secure due to this agentless capabilities and open SSH security features. Ansible does not need any special system administration skills to install and use it. Disadvantage of usage Ansible. Insufficient user interface. Though Ansible Tower is GUI, but it is still in development stage. Cannot achieve full automation by Ansible, new to the market, therefore limited support and document is available. Traditional deployment era. Early on, organizations ran applications on physical servers. There was no way to define resource boundaries for applications in a physical server, and this caused resource allocation issues. For example, if multiple applications run on a physical server, there can be instances where one application would take up most of the resources, and as a result, the other applications would underperform. Virtualized deployment era. As a solution, virtualization was introduced. It allows you to run multiple virtual machines, VMs, on a single physical server's CPU. Virtualization allows applications to be isolated between VMs and provides a level of security as the information of one application cannot be freely accessed by another application. Virtualization allows better utilization of resources in a physical server and allows better scalability. Each VM is a full machine running all the components, including its own operating system, on top of the virtualized hardware. Container deployment era. Containers are similar to VMs, but they have relaxed isolation properties to share the operating system, OS, among the applications. Therefore, containers are considered lightweight. Similar to a VM, a container has its own file system, share of CPU, memory, process space, and more. As they are decoupled from the underlying infrastructure, they are portable across clouds and OS distributions. Containers have become popular. Agile application creation and deployment. Increased ease and efficiency of container image creation compared to VM image use. Continuous development, integration, and deployment provides for reliable and frequent container image build and deployment with quick and efficient rollbacks, due to image immutability. Dev and Ops separation of concerns. Create application container images at build, release time rather than deployment time, thereby decoupling applications from infrastructure. Observability. Not only surfaces OS-level information and metrics, but also application health and other signals. Environmental consistency across development, testing, and production. Runs the same on a laptop as it does in the cloud. Cloud and OS distribution portability. Runs on Ubuntu, RHEL, CoreOS, on-premises, on major public clouds, and anywhere else. Application-centric management. Raises the level of abstraction from running an OS on virtual hardware to running an application on an OS using logical resources. Loosely coupled, distributed, elastic, liberated microservices. Applications are broken into smaller, independent pieces and can be deployed and managed dynamically. Not a monolithic stack running on one big single-purpose machine. Resource isolation. Predictable application performance. Resource utilization, high efficiency and density.